everyone, and welcome back to the Deep Dive. Today, we're going to be taking a look at a university program in India, a Bachelor of Engineering in Manufacturing Process and Automation Engineering. You might see it shortened to MPAE. We've got some really interesting stuff to go over. Course descriptions, examination guidelines, all that good stuff.
Nice. Sounds interesting.
Yeah, and what's really caught our attention is, well, this program seems like it had the potential to be just absolutely top-notch. But there were some missed opportunities along the way.
Yeah, when you look at the curriculum on the surface, it is remarkably ambitious. It covers a wide range of topics.
Oh, yeah.
Like everything from traditional manufacturing techniques to robotics and computer numerical control machining, even delving into management and societal aspects. That's something you don't often see in engineering programs.
Yeah, the program is structured as 8 semesters, filled with theory courses and hands-on lab work.
Lots to...
They also require industrial training, which is great. And a major capstone project. Plus, there's this almost unique credit system where you can potentially earn more credits than required to graduate.
Really?
Yeah. It seems like a student could strategically use this to boost their final grade. But let's break down the program's core strengths. What really stood out to you?
I think the emphasis on practical application through labs and mandatory industrial training, that's a huge plus. It shows a recognition that manufacturing isn't just about textbook knowledge. You got to apply those concepts in real-world scenarios.
Yeah, you got to get your hands dirty.
Exactly.
Right. I love that focus on hands-on experience, especially in a field like manufacturing where being able to troubleshoot and solve problems on the fly is so crucial.
Oh yeah, for sure. Another strength is the program's multidisciplinary approach, blending mechanical, electrical, and computer engineering. Graduates would be incredibly versatile.
Yeah.
They'd have the skills to design a product, program a robot to manufacture it, and then optimize the entire production process.
Now that you mention it, that multidisciplinary aspect really jumps out. These graduates wouldn't be siloed into one specific area of expertise. They'd be able to understand it and contribute to the entire manufacturing ecosystem.
Exactly. However, while the program has a solid foundation, there are some areas where it could have been more forward-thinking.
Okay, so let's unpack these missed opportunities. What was the program missing?
One of the most glaring omissions is the lack of integration of Industry 4.0 principles. Like, imagine if the curriculum had embraced the power of interconnected systems, data analytics, and automation. Like, think of a factory where machines can automatically order replacement parts when sensors detect wear and tear. That's Industry 4.0 in action.
Wow, yeah, that makes a lot of sense. Industry 4.0 is transforming the manufacturing landscape. So what specific elements of Industry 4.0 could have been incorporated into the curriculum?
Well, for starters, they could have included modules on digital twins, which are virtual representations of physical assets. These allow engineers to simulate and optimize processes before implementing them in the real world.
Interesting.
Another key area is predictive maintenance. Uses data analysis to anticipate equipment failures and schedule maintenance proactively.
So it sounds like these Industry 4.0 concepts would have given the students a huge advantage in the job market. Instead of just knowing how to operate a machine, they'd be able to analyze data, optimize performance, and make data-driven decisions.
Exactly. And while the industrial training component is valuable, the type of collaboration with industry partners could have been much more robust.
I'm curious about that. What specific types of collaboration would have been beneficial?
Think about joint research projects with companies, working on cutting-edge technologies, or guest lectures by industry experts, sharing real-world challenges and solutions, or internships that expose students to the realities of a modern, interconnected factory.
So instead of relying solely on academic exercises, the students would have had the chance to tackle real-world problems alongside experienced professionals. That's invaluable experience.
Absolutely. And it leads us to another significant missed opportunity, a lack of focus on entrepreneurship.
Interesting. Why do you think that's so important, especially in the context of this program?
Well, India is pushing initiatives like Make in India and Startup India, which aim to boost domestic manufacturing and entrepreneurship. Given that context, why not equip these graduates with the skills and mindset to launch their own manufacturing ventures?
You're right. It's a bit of a disconnect. You have students learning all these technical skills, but perhaps not being encouraged to think about how they could apply that knowledge, to create something new, to solve a problem, or even to build their own businesses.
Precisely. And there are several specific ways they could have addressed this.
Let's delve into those solutions in the next part of our deep dive. But for now, we've established that. While the Bachelor of Engineering and Manufacturing process in automation engineering has a strong foundation, there are some areas where it could have been more aligned with the evolving needs of the industry.
One way would have been just incorporating modules on like business planning and intellectual property, fundraising, even basic workshops or guest lectures from successful manufacturing entrepreneurs. Could have made a big difference.
Yeah, I think that would have been pretty cool. Exposing students to real-world entrepreneurial experiences could have sparked some innovative ideas. Did you have any specific examples in mind?
Oh yeah, absolutely. Take the Massachusetts Institute of Technology, MIT in the US. Their program has a strong entrepreneurial focus, with opportunities for students to engage in hands-on projects, participate in pitch competitions, even launch their own startups while still in school.
Wow.
They have a really vibrant ecosystem that supports student ventures and connects them with mentors and investors.
So it's not just about adding a few business courses to the curriculum. It's about creating an environment where innovation and entrepreneurship are actively encouraged and supported.
Exactly. Universities can play a crucial role in fostering that entrepreneurial spirit. Another interesting example is RWTH Aachen University in Germany. They've partnered with Fraunhofer Institutes, which are renowned for their applied research, to create a unique learning environment where students can work alongside industry professionals on cutting-edge projects.
Very cool.
This type of collaboration not only provides valuable practical experience, but also exposes students to potential business opportunities.
That's a fantastic example of how academia and industry can collaborate to create a win-win situation for both students and companies.
Precisely. Now let's shift our focus back to the curriculum evolution. As we were discussing earlier, the MPAE program could have benefited from incorporating some key Industry 4.0 elements.
Right, we talked about how they missed out on integrating concepts, like digital twins and predictive maintenance. How could they have implemented those into the existing coursework?
Well, instead of just teaching traditional quality control methods, they could have introduced modules on AI-powered quality assurance systems that use machine learning algorithms to detect defects in real time.
That sounds much more dynamic than simply inspecting products manually. What other practical examples come to mind?
Imagine incorporating simulation software into the design courses. Students could create digital twins of their product designs and then test them virtually under various conditions, optimizing for performance and manufacturability before even building a physical prototype.
Oh, that's interesting. It's almost like giving them a virtual sandbox to experiment and refine their designs before they hit the real world. That could save a lot of time and resources in the long run.
Exactly. And remember that unique credit system we mentioned earlier, where students could earn more credits than required.
Yeah, that seemed like a unique feature of the program.
They could have leveraged that system.
Yeah.
To encourage students to explore these emerging areas, imagine offering bonus credits for elective courses on topics like 3D printing, robotics, or industrial Internet of Things.
That would definitely incentivize students to go beyond the core curriculum and delve into specialized areas that align with their interests and career goals.
Precisely. And speaking of incentives, let's revisit that topic of industry collaboration. We talked about the need for more robust partnerships.
Yeah, you mentioned joint research projects, guest lectures, and internships. How do we ensure those collaborations are truly beneficial for both sides? Sometimes companies just want cheap labor.
You raise a valid point. We need to move beyond transactional relationships and create partnerships where there's a genuine exchange of knowledge and value. Take, for instance, the University of Sheffield's Advanced Manufacturing Research Center, AMRC, in the UK. They've developed a highly successful model of collaboration with companies like Boeing and Rolls-Royce.
What makes their model so effective?
They have a shared facility where university researchers and industry engineers work side by side on real-world problems, developing new technologies and processes. The companies benefit from access to cutting-edge research and a pipeline of highly skilled talent, while the university benefits from funding, real-world insights, and opportunities for students to gain practical experience.
That sounds like a great example of a mutually beneficial partnership. Are there any other innovative approaches to industry collaboration that you've observed?
Definitely. Look at the Danish Technological Institute, DTI. They act as a bridge between academia and industry, facilitating knowledge transfer and collaborative projects. They might identify a company with a specific manufacturing challenge and then connect them with university researchers who have the expertise to help solve it.
So they're almost like matchmakers, connecting companies with the right research partners to tackle specific challenges. It seems like there are so many creative ways to bridge the gap between academia and industry.
Absolutely. It's about thinking outside the traditional box and finding innovative ways to create value for everyone involved. And these types of collaborations don't have to be limited to large multinational corporations.
Right. We often focus on the big players, but small and medium-sized enterprises. SMEs also have a lot to offer. How can they be engaged in these partnerships?
Many SMEs might not have the resources for their own dedicated research and development departments. That's where universities can step in. Imagine creating a program where student teams work with local SMEs on projects like process optimization, quality control, or even designing new products.
That would be a fantastic way for students to gain practical experience while also helping these businesses innovate and grow. It's almost like a consulting service powered by student talent.
Exactly. And the universities could even create dedicated centers or programs to facilitate these collaborations, providing mentorship, resources, and support to both the students and the SME partners.
Now that we've explored some innovative solutions, what advice would you give to universities that are looking to implement these changes?
I would say start small, focus on building momentum, and don't be afraid to experiment.
It sounds like a phased approach might be more manageable than trying to overhaul the entire system overnight. Are there any concrete first steps that universities could take?
Absolutely. Reach out to a few companies in your region and explore potential partnerships. Organize a workshop or a guest lecture series on Industry 4.0 or entrepreneurship. Launch a pilot project with local SME. These small steps can create a ripple effect and pave the way for more substantial changes.
So it's about creating a culture of continuous improvement and collaboration.
Exactly. And remember, change doesn't happen in isolation. It requires buy-in from multiple stakeholders: faculty, students, industry partners, even policymakers.
That makes sense. It's a collective effort that requires everyone to be on board and working towards a shared vision. But before we get too carried away with grand visions, let's bring it back to the program that inspired this whole conversation: the Bachelor of Engineering in Manufacturing Process and Automation Engineering. Yeah, it's easy to focus on the areas where this program could have been even stronger.
Right.
But we shouldn't forget that it still laid a solid groundwork.
That's right. The program clearly demonstrates an understanding of core manufacturing principles and a commitment to hands-on learning. Those are valuable assets to build upon.
And we can't overlook the efforts of the faculty and students involved.
Yep.
They may not have had access to all the latest advancements, but they were still striving to learn and innovate within their context.
Absolutely. It's important to acknowledge the unique challenges faced by the Indian education system, including limitations in resources and infrastructure. Despite these obstacles, the program managed to create a comprehensive curriculum and incorporate practical training elements. That's commendable.
It's a reminder that progress isn't always linear. There will be bumps along the way, but each step forward contributes to a larger journey of improvement.
Well said. And hopefully, this deep dive will spark conversations and inspire positive changes, not just within this specific program, but within the broader manufacturing education landscape.
It's fascinating to think about how much the field of manufacturing has evolved in recent years, and that pace of change is only going to accelerate. If you were designing a manufacturing program from scratch today, knowing everything we've discussed, what would be your top priority?
Well, that's a tough one. If I had to choose just one, it would be to instill a culture of continuous learning and adaptation. That traditional model of education, where you learn something for a set period and then you're done. It simply doesn't cut it in a field as dynamic as manufacturing.
Yeah, because by the time these students graduate, the technologies they learned in their first year might already be outdated.
Exactly. So it's less about teaching specific skills and more about equipping students with the tools and mindset to become lifelong learners.
So it's about teaching them how to learn, rather than what to learn.
Precisely. It's about giving them the ability to identify emerging trends, acquire new knowledge quickly, and adapt to changing circumstances. And that means developing critical thinking skills, problem-solving abilities, and a knack for effective collaboration.
It sounds like we're talking about more than just technical skills here. It's about fostering adaptability, resilience, and a genuine curiosity for exploring new frontiers.
You've hit the nail on the head. Those qualities will serve them well, not just in a manufacturing career, but in any path they choose.
It's about preparing them not just for their first job, but for their entire career, for a world that's constantly evolving.
That's the ultimate goal of education, isn't it? To empower individuals to navigate the complexities of a rapidly changing world and to contribute meaningfully to society.
Well said. And on that note, I think we've covered a lot of ground today. We've explored the strengths and weaknesses of a specific manufacturing program, delved into the transformative power of Industry 4.0, and even brainstormed ways to foster a more entrepreneurial spirit within engineering education.
It's been a pleasure exploring these ideas with you. The future of manufacturing is full of exciting possibilities, and I'm optimistic that the next generation of engineers will be well equipped to lead the way.
And for our listener who brought us this fascinating program, we hope this deep dive has provided you with valuable insights and food for thought as you continue your own exploration of the manufacturing world. Until next time, keep diving deep and keep those brains churning apart.